Good day everyone. Welcome to lecture 14. Today we will be talking about derivative as instantaneous rate of change. Balikan lang natin from last week, you discussed about derivatives, and for this week, we will discuss various applications of derivatives. Actually, may isang application na kayo na-discuss, which is using derivative to get the slope of the tangent line and the normal line to a curve. Ano pa ba yung ibang applications ng derivative? So I will mention a few. We can use derivative to describe the rate of change of one variable with respect to the other. An example will be change in the position and velocity of a moving object with respect to time. Pwede rin natin gamitin ito sa pag-calculate ng marginal cost, revenue, or profit, or producing a certain product. Pwede rin siyang gamitin sa optimization problems such as getting the maximum or minimum area, amount of material used, profit, and a lot more. We will discuss these applications one by one in the succeeding days, but for today, first, we will define derivative as instantaneous rate of change, and second, we will discuss its application on rectilinear motion. So let us start by defining the average rate of change. If we have y equals f of x, then the average rate of change of y with respect to x on this interval is just given by the change in y, or delta y, divided by the change in x, or delta x. Okay? Our change in y here is just given by the difference in the functional value at the endpoints. We have f of x plus h minus f of x, divided by the change of x is just x plus h minus x, which is just h. So our h here is the length of your interval. Let's illustrate this by doing this example. If we have a free-falling object dropped from a height of 100 feet, and its height is given by this function, s of t, with respect to time t, equals negative 16t squared plus 100, we want to get the average rate of change of the height over, first, this interval 1, 2. So again, ang definition ng average rate of change ay change in y over change in x. So in this case, you have change of s over change in t. So the change in s would be given by s of 2 minus s of 1. So let us first compute for that. So for s of 1, just simply plug it in. So that's this one. And this is just 84 if you compute. So madali lang to, no? Just substitute. And then s of 2, substitute again, you'll get 36. Hence, we know that the average rate of change of the height from t equals 1 to t equals 2 is just equal to s of 2, 36, minus s of 1, 84, divided by 2 minus 1. So this equals negative 48 feet per second. Okay. So now let's see what will happen if we make this interval smaller. Let's say we consider 1.5 here. So we get s of 1.5. We have 64. So we can get the average rate of change, which is 64. That's s of 1.5. And then we already have s of 1 earlier. That's 84. Divided by the length of the interval, which is just 0.5. So therefore, we have negative 40 feet per second. Okay. So let's try to make it smaller again. For the third interval, we consider 1.1. The length of our interval here is 0.1. Okay. So s of 1.1 is 80.64. Hence, the average rate of change is 80.64 minus s of 1, which is 84 again, divided by 1.1 minus 1, which is just 0.1. And we have negative 33.6 feet per second. Okay, so if we continue doing this, if we continue to make our interval smaller and smaller, we will get this information here. So for this one, so the first row will be the delta t's. Okay, so as you can see, the delta t's are getting smaller and smaller. It's approaching 0. So we have here, what can you observe with our average rate of change? As your delta t goes to 0, your average rate of change actually approaches negative 32. So it seems reasonable to conclude that the instantaneous rate of change of the height when t equals 1 is negative 32 feet per second. Okay? And now, we have the definition of the instantaneous rate of change, which is just the limit of the average rate of change. So in this one, this is the average rate of change, and you just take the limit as h approaches 0, meaning you're making the interval smaller and smaller as we have illustrated earlier. And this expression should look very familiar to you. This one is the limit definition of the derivative of f of x. Hence, f prime of x is also the instantaneous rate of change of y at x. Okay? Let's start rectilinear motion with this example. At time t equals 0, we have a diver jumping from a diving board that is 32 feet high. The position of the diver is given by this function, s of t equals negative 16t squared plus 16t plus 32. Our s of t here is measured in feet, and our t here is measured in seconds. Okay? So before we answer the first question, describe muna natin kung ano yung motion ng diver. So the graph of this function is not actually hard to describe. If you recall, with your graphs of functions on our first meeting, this function has a graph of a parabola that is opening downwards since our leading coefficient is negative, which is true because the diver is going down. Okay? So at t equals 0, the diver is at 32 feet high. So let's say this is 32. And this is our starting point. This is at t equals 0, the height is 32, and the diver jump in a motion of a parabola opening downward, so something like this. Okay. So the first question would be, when does the diver hit the water? So take note that the function s of t measures how high the diver is. That means the measure of the distance of the diver from the water. So let's look at the graph here. The instant that the diver hit the water would be at this point. Okay, so assuming this is the water, so this would be that point. And this is the point where your position is equal to 0. Okay? So that means, to answer letter A, we will let s of t equal 0. So we will solve for t such that s of t equals 0. We equate this one to 0. We have this expression. Again, this is a quadratic equation, so you want to factor it out in order to get the zeros. Factoring out negative 16, you get negative 16 times t squared minus t minus 2. And factoring this furthermore will result to this expression. As you can see, we get two values of t here. We have t equals negative 1 or t equals 2. Okay. But the question is, should we consider both zeros? The answer is no, because we are talking about t as time, and time cannot be negative. So we only consider t equals 2, hence we have the conclusion that the diver will hit the water after 2 seconds. Okay? So for letter A, we have the first function that we're going to talk about in rectilinear motion, which is s of t. Okay? Or this is called the position function again. Let me denote this as s of t. Okay? Moving on to letter B. we are asked to find the diverse velocity at impact. The velocity will just be the rate of change of the position. Hence, to get the velocity, we just simply differentiate the position function. And that will be our second function, which is the velocity function. So we have here v of t, or the velocity function. This is just equal to the derivative of your position function. Hence, we just simply differentiate s of t here. The derivative of this, we just use power rule. So bring out 2, you have negative 32, then you have t here, plus the derivative of this is 16, and the derivative of this is 0. Hence, the velocity function is negative 32t plus 16. This is your velocity at any time t, but we are asked for the diverse velocity at impact. That means the moment that it hits the water, and that will be at time t equals 2. And so we get v of 2. We have negative 32 times 2 plus 16. Okay? So this is negative 48 feet per second. This is the diverse velocity at impact. Now for letter C, we are asked to find the diverse acceleration at any time t. Now the acceleration here would be the rate of change of the velocity. Hence, to get the acceleration, you just differentiate the velocity function. So that's our third function. So you have the acceleration function. So a of t here is just equal to the derivative of the velocity function. But again, the velocity function is just the derivative of the position function. So therefore, if you want to get the acceleration, you can get the derivative of the position function to get v of t and differentiate it once more. In other words, your acceleration function is just also the second derivative of your position function. Okay? And going back, so from letter B, we have the velocity function v of t to be equal to negative 32t plus 16. Since we're getting the acceleration, we differentiate v of t. The derivative of this will just be negative 32. Hence, the acceleration at any time t is constant and is equal to negative 32 feet per second square. Again, we have three functions here. First is the position function. This describes the position of the object at any time t. And we have the velocity function to be the derivative of the position function, and the acceleration function to be the derivative of the velocity function, which is also the second derivative of our position function. Now for our next example, we have a ball that is thrown vertically upward from the ground. Its initial velocity is 64 feet per second. The positive direction will be the distance from its starting point upward. And the equation of the motion is given by this function. S of t equals negative 16t squared plus 64t. So observe natin na itong function na to, ang graph nito ay, again, a parabola that's opening downwards. Let t be the seconds that has elapsed since the ball was thrown. And s would be the distance of the ball from the starting point at t seconds. First, we want to find the instantaneous velocity and speed of the ball at the end of t seconds. So again, the velocity is just a derivative of your position function. The position function is negative 16t squared plus 64t. Derivative of this is negative 32. Ito naman 64. Hence, ito nga, ang nakuha nating velocity function ay negative 32t plus 64. And we want to get the instantaneous velocity at time equals 3. So substitute 3 here. You'll get negative 32 times 3 plus 64 and that equals negative 32 feet per second. So this is the instantaneous velocity at t equals 3. And moreover, since yung speed natin, so that's just the velocity without the direction, meaning that's the velocity without the sign, so you just take the absolute value. So the speed is always positive. And hence, the speed of the ball is just absolute value of negative 32, which is 32 feet per second. Okay. Letter B, how many seconds does it take for the ball to reach its highest point, and how high will it go? Okay? So again, sabi ko nga, ang graph nito ay isang parabola opening downwards, like this. Okay? So kung iisipin nyo, ano ba yung highest point ng ating parabola? Yung highest point ng ating parabola will just be the vertex here. Okay? So therefore, we can think of the velocity at this point to be the slope of this tangent line. Okay? And this tangent line here is horizontal, okay, since this is the vertex, and the slope of this is 0, so this is the point where your velocity function equals 0. So that means the moment that the ball reaches highest point would be at v of t equals 0. Okay? So you're just getting the zeros of your derivative. So again, at maximum height, the velocity of the object is 0. So we equate v of t equals 0. We have earlier that's negative 32 plus t plus 64. And so we get this factored form. Hence, our t is equal to 2. Okay. And now, paano natin kukunin yung maximum height? So, go back lang tayo doon sa ating position function. And tignan natin kung ano yung position niya at t equals 2. Kasi dito nga siya nagkakaroon ng maximum height. So, we have the maximum height to be s of 2. So, kung mapansin nyo, yung s of 2, siya lang yung second coordinate sa inyong vertex at ito yung first coordinate, yung t equals 2. So, you have negative 16 times 2 squared plus 64 times 2. Pilnagin lang natin. That's equals 64 feet. Okay? So, we have at 2 seconds, we have the maximum height, which is 64 feet. For letter C, how many seconds does it take the ball to reach the ground? So, ibig sabihin ng nasa ground siya, again, is, since yung s of t ay measure ng height from the ground, then, yung moment na nasa ground siya would be, again, if s of t equals 0. So, para lang siya example natin sa diver kanina, kung kailan siya nag-hit sa water. Okay, so we equate s of t to 0. We have this. Factoring it out, we can factor out negative 16t. You have times t minus 4. You have two solutions here, t equals 0 and t equals 4. Pero again, t equals 0, ito yung initial time natin, no? So, ibig sabihin, ito pa lang yung moment na ibabato natin yung ball. So, therefore, we will consider t equals 4 as our answer. So, after 4 seconds, the ball will reach the ground. For letter D, we want to get the instantaneous velocity upon reaching the ground. So, again, the ball reached the ground at t equals 4. So, kukunin mo lang ang v of 4. That's negative 32 times 4 plus 64. Plug in lang. So, you have negative 64 feet per second. So, this is the instantaneous velocity upon reaching the ground. And now we have this remark. So, we're considering a motion along a horizontal line. Maaari nating malaman yung direction ng inyong object based on the sign of its velocity. At kung yung object ay nag-speed up or nag-slow down based on the signs of your velocity and acceleration function. Okay, we have the following. So, if your v of t is positive, then we say that the particle is moving to the right. And if v of t is less than 0, then we say that the particle is moving to the left. And if v of t equals 0, then this is the moment when your particle reverses its direction at time t. Now, if your acceleration is positive and your velocity is positive, then the particle is speeding up. But if it's negative, then the particle is slowing down. And if your acceleration now is negative, but your velocity is positive, then it's slowing down. If it's negative, then it's speeding up. Okay? Actually, we can summarize remark 4 and 5 by saying that if both the velocity and the acceleration have the same sign, that is, if both of them are positive or both of them are negative, then the particle is speeding up. Okay? However, if they have different signs, then the particle is slowing down. Okay? And moreover, if a of t equals 0, that means you don't have a change in your velocity, then we say that the particle has a constant velocity at time. Okay? So we use the previous remark to answer this example. We have here a particle moving along a horizontal line according to this position function. S of t equals 2t cubed minus 4t squared plus 2t minus 1. Yung S of t natin, this represents the distance from the starting point. First, we want to determine the intervals for which the particle is moving to the right and left, and also the instants when the particle reverses its direction. Second, we want to determine when is the particle speeding up and slowing down. Okay? Recall natin yung previous remark, malalaman natin ang direction ng isang particle based on the sign of v of t. And malalaman natin kung speeding up and slowing down based on the signs of v of t and a of t. So to solve this problem, our goal here is to make a table of signs that would summarize the signs of our velocity function and acceleration function. So first, the question is, when could the signs of v of t and a of t possibly change? The answer is the values of t for which v of t equals 0 and a of t equals 0. Okay? So the first step into solving this kind of problem is to get the zeros of your velocity and acceleration function. Getting the velocity function, which is just the derivative of s. So mangyari dito, you have just a power rule lang, no? So you have 60 squared minus 80 plus 2. That's this one. Again, you're getting the 0, so you factor it out. Factoring out 2, you have 2 times the quantity 3t squared minus 40 plus 1. And factoring this out, you'll get this form. Okay? So dito, meron tayong t equals 1/3 and t equals 1 as our 0. Right? Now for a of t, differentiate si v of t. We can work with this one. Ang derivative nito ay 12t minus 8. This one. And if you factor that out, that's 4 times 3t minus 2. Okay? So, ang 0 natin dito ay 2/3. So, anong gagawin natin sa mga zeros? Hatiin natin yung number line based on those zeros. And we will have intervals here. So, ito yung magiging itsura ng table of signs natin sa upper row. Nandito yung mga intervals. Again, sabi ko, hatiin natin siya sa 1/3. Ito yung hati na yon. Hatiin natin siya sa 2/3 at sa 1. Okay? Moreover, observe na yung t natin ay greater than 0, kaya nag-start tayo sa interval na 0 to 1/3. Okay? Tapos, dito sa ating left column, we will put here the factors of our v of t and a of t. So, start muna tayo sa v of t, no? Yung 3t minus 1 and t minus 1. Okay. So, maybe na-encounter nyo nang gumawa ng table of signs in your prerequisite course. But, let me recall this again and discuss this step by step. So, ang goal nyo lang dito technically is to fill out the table. So, ano i-fill out nyo? Dito, ilalagay nyo lang yung sign nitong factor na to on the interval sa taas. Okay? So, generally, para gawin to, pwede kayong mag-test points. Let's see, dito sa first interval, 0 to 1/3, kuha tayo ng isang point sa loob niyan. Ang 1/3 ay 0.33. So, pasok dyan yung 0.25. And then, plug it here. You have 3 times 0.25. That's 0.75 minus 1. So, you have negative 0.25. So, that will be negative. Kaya negative nandito. Okay? Sige, ulitin natin yun dito. Ang 1/3 is approximately 0.33. Ang 2/3 is approximately 0.67. Hence, 0.5 is in this interval. We can use that as our test point. So, here we have 3 times 0.5 minus 1. Kaya ito positive. Right? Yung 2/3 to 1 naman, ang 2/3 ay 0.67. Ito ay 1, of course. So, pwedeng kunin ang 0.7, I think. So, 0.7, 3 times 0.7 is 2.1 minus 1. This is also positive. Okay. Lastly, from 1 to infinity, so 2. Nasa loob niyan. So, 3 times 2 is 6 minus 1 is 5, which is positive. Okay. So, ito yung signs for our first row. Pero actually, for linear factors, meron diyang shortcut, no? If your leading coefficient is positive, that means the coefficient of your t here is positive. Totoo naman kasi dito. So, gagawin nyo, kunin nyo lang yung 0 nito. That's 1/3. Locate natin nasan yung 1/3. No? Nandito siya. Ito yung hati ng 1/3. Okay? Tapos, lahat ng nasa left niyan would be negative. Okay? This is precisely because 3t minus 1 is less than 0 when t is less than 1/3. Okay? And, moreover, 3t minus 1 is greater than 0 exactly when t is greater than 1/3. Ibig sabihin, lahat ng nasa left ng partition na to ay negative, tas lahat ng nasa right niya ay positive, which is true. Tama? Okay? Pero reminder ko lang, kapag ang leading coefficient mo ay negative naman, then mag-switch yung ating mga signs. Kapag nagkataon na this is 1 minus 3t, then ang mangyayari, lahat ng nasa left ay positive, lahat ng nasa right ay negative. So, kung 1 minus 3t yan, magkakaroon ka dito dapat ng positive, negative, negative, negative. Okay? So, nagets ba yun? So, you can use that technique for linear factors. Okay? So, gamitin na natin yun sa t minus 1. Ang 0 ng t minus 1 ay 1. So, that's this part. And indeed, lahat ng nasa left niya would be negative and lahat ng nasa right niya would be positive. Now that we have the signs of the factors of our v of t, we can now solve for the sign of v of t. So, observe natin yung form muna ng v of t. Yung 2, positive yan, no? So, wala siyang effect. Yung sign niya, walang effect doon sa v of t kasi positive nga siya. So, to get the sign of v of t, you can just look at the sign of the product of these two factors. Okay? So, ganito yan. Negative times negative, you have positive, right? Positive times negative, you have negative. Positive times negative, you have negative. And then positive times positive, you have positive. And for a of t, so you have 4 times 3t minus 2. Using the same argument, 4 is always positive. It doesn't affect anything. Its sign doesn't affect the product. So you just look at the sign of 3t minus 2. The 0 of 3t minus 2 is 2/3. So that's this part. So everything to the left is negative. Everything to the right is positive. Okay? So there you go. You have the signs for v of t and a of t. Pwede na natin gamitin yung remark before. To answer our first question, kailan siya papuntang right? The particle will be moving to the right if your velocity is greater than 0. So, tingnan nyo lang yung row ng v of t. Kailan ba ito positive? Ito, at saka ito. So, we have this. We say that the particle is moving to the right when t is an element of here, 0 to 1/3. And here, 1 to infinity. And moving to the left otherwise, that will be these intervals, 1/3 to 2/3 and 2/3 to 1. But in our final answer, pinagsama na natin sila. This is because we can include 2/3. This is because v of t is not 0 at t equals 2/3. So actually, pwede nyo na rin i-plug in yung 2/3 dito and you can verify that v of t is indeed non-zero and moreover less than 0 at that point. Okay? To answer the question also, kailan nag-reverse ang ating direction? That's when v of t equals 0. So that's at t equal 1/3 and t equals 1. And you can verify that in our table. At t equals 1/3 here, your your particle changes from the positive direction to the negative direction. At t equals 1, your particle changes from the negative direction to the positive direction. Tapos, kailan naman siya nag-speed up at nag-slow down? So, katulad nga sinabi ko kanina, nag-speed up siya kapag same ang sign ng v of t at a of t. So, let's look at the last two rows. So, ito yun, no? Yung isa, kasi parehong negative. Tapos, ito yung isa, dahil parehong positive. Therefore, the particle speeds up at the interval 1/3 to 2/3, union, this part, 1 to infinity, and slows down otherwise. So, at 0 to 1/3, positive, negative kasi siya, different. And at 2/3 to 1, negative, positive kasi siya. Okay? Okay, so, to recap again yung ginawa natin dito, ang una natin ginawa ay get the zeros of v of t and a of t. Okay? So, we divided our interval based on those zeros here. So, ito yung mga intervals sa taas. Tapos, dito yung mga factors. And then, we complete the table of signs here. So, after completing the table of signs, you can now use the remark earlier to get your conclusion. Okay? And itong paggawa ng table of signs, actually, magandang practice na rin ito sa inyo for our next lecture. Okay? Yeah. So we have here the last example for this lecture video. In this problem, we have a particle moving along the real number line. The position function is given by this. X of t equals e to the quantity 2t plus 3 minus 2e to the quantity t plus 5. So, differential ng dalawang exponential functions. Our x here is the directed distance of the particle from the origin after t seconds. Our goal is to find the time when the particle changes direction. So again, ang isang particle ay nag-change ng direction kapag ang velocity natin ay equal sa 0. So we first get v of t. That's derivative of this. Ito yung lecture nyo last time, right? To differentiate an exponential function, in particular of the form e to the u, you just copy this one. So, copying that, you have e to the quantity 2t plus 3, and then by chain rule, multiply by the derivative of this, which is just 2. So, we have this for the first one. For the second one, minus 2e to the, copy ulit, t plus 5. And ito na yun, kasi ang derivative ng t plus 5 ay equal lang sa 1. So, this is your velocity function. And you equate that to 0 and solve for t. Because, again, the particle changes direction at p of t equals 0. So, ito na yung magiging equation natin. Here, just equate this to 0. And this is an exponential equation. I-recall natin, paano ba natin sinasolve ang isang exponential equation? Well, one way to get the 0 is to make both sides of the same base. So, ibig sabihin, dapat magkaroon tayo ng same base sa both sides. At pwede natin yung gawin by transposing this one to the other side. Kaya meron tayong ganito. 2e to the quantity 2t plus 3 equals 2e to the quantity t plus 5. Furthermore, we can divide 2. So, ang matitira na lang sa atin ay e to the quantity 2t plus 3 equals e to the quantity t plus 5. Same ang base sila, parehong e. Therefore, we can equate the exponents will result to 2t plus 3 equals t plus 5, and hence t equals 2. Okay, so therefore at t equals 2, our v of t equals 0, and the particle changes direction after 2 seconds. Okay. So and that's it for our lecture video. So here are more exercises that you can answer for practice. So yung 1 and 2 dito, just getting the velocity and acceleration function. So yung number 3, katulad nung kanina, getting the maximum height and kung ano yung velocity niya upon striking the ground. And yung last natin would be similar to the table of signs that we did earlier. You have to determine when the object is moving to the left and right and speeding up and slowing down. So this might also be discussed by a discussion teacher. Okay, bye!